Right. Good afternoon to everyone. So, uh, today topic is, so this is the physical geology first semester. Today topic is orogeny, right? So, what is orogeny? Coming to the point. So, right now, so to feel some of the field geologists, the term this orogeny, it represents a penetrative deformation of the earth at crust. So this is the associated with phases of metamorphism and igneous activity along restricted and commonly linear zones and within a limited time interval, right? So, however, our increasing understanding of the geology of lithospheres allows some of the geologists today to view orogenesis on a larger scale as the interaction of a series of geodynamic process. So the orogenesis is the most complex of tectonic process, right? And interpreting ancient mountain belts. So that is one of the greatest challenges our geologist faces today, right? So, as originally defined by Gilbert, is that Gilbert? Gilbert in the year of 1980 and orogeny. So, orogeny means so oros, oros. So, oros is a Greek word, right? This meaning mountain. Okay, mountain. So and gens. This oros and gens. So this meaning stemming from, right? Stemming from. So an orogeny is simply a period of mountain building, right? So the orogeny literally the process of formation of mountains, right? So the term orogeny came into use in the middle of the 19th century. 19th century, when the process was thought it to include both the deformation of rocks within the mountains and also the creation of the mountainous topography. These two, right? So only much later it was released that the two process deformation of rocks within the mountains and the creation of the mountainous topography, right? So these two processes were mostly not closely related either in origin or in time, right? So nowadays most of the geologists regard the formation of mountainous topography as postorogenic. 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 So now by present geological usage, the orogeny is the process by which structures within fold belt mountainous areas were formed, including thrusting and folding, faultings in the outer and higher layer, and plastic folding, metamorphism, and also plutonism. So in the inner and deeper layers. So the orogeny or orogenesis, the formation of mountains, right? Means formation of mountains. So it is brought about by the movements of rigid plates making up the earth crust, right? Earth crust. So when the two plates collide at a destructive margin rocks, it becomes folded and lifted to form chains of fold mountains. Fold mountains means such as the young fold mountains of the Himalayas, right? So now the orogeny. The orogeny is primarily the mechanism by which mountains are built on contents due to the large structural deformation of the Earth's lithosphere. Earth's lithosphere, right? It caused by the plate tectonics, right? Plate tectonics. So the orogenesis involves so these following methods. That one structural deformation of the rocks and faulting of rocks and folding of rocks and igneous process and metamorphism and glaciation and erosion and also sedimentation. So mountains are born and it have finite life of span. So some of the young mountains are high and steep and growing upward, right? So middle-aged mountains are cut by erosion and old mountains are deeply eroded and often buried, right? So we have to note here that the constructive processes like deformation, folding, uh, this faulting, igneous process, and sedimentation build mountains up, right? So on the contrary, the destructive processes like erosion and these glaciations, right? So these tear them back down again also, right? Now you see here, this is the your theory question in your examination. So they are asking in your examination, write about forms of mountains or mountain forms, right? So you wrote this properly, okay? So a mountain may have several forms, right? So that are important among them are here. First one is mountain ridge and mountain range and mountain change and mountain system and also mountain group and last one is cordillera, right? So these are these some of the mountain forms. So first one you see here mountain ridge. So mountain ridge means so it is a linear and steep-sided high hill. This one, right? High hill or spur. So the slope of one side of ridge is steep and one while the other side is of moderate slope, right? You see here this one and this one, right? So a ridge, however, it may have symmetrical slope, right? Symmetrical slopes on both sides, this side and this side. So in the some of the example, Shimla. Shimla is one of the ridges there. So that Shimla ridge is a good example of mountain ridge. This one, okay? This is called mountain ridge. And next one is mountain range. So mountain range, what is mountain range? So mountain range is a linear system of mountains and hills having several ridges, right? These ridges and peaks and summits and also valleys. So the mountain ridge, a mountain range is a linear or curved sequence of mountains. So that are connected by high ground, right? So it is a relatively narrow and elongated feature and typically with a distinct axis, right? Or trend. So these mountain ranges can be formed by various geological process and including uplift and folding, faulting, right? So some of the examples of mountain ranges include the Himalayas, right? Himalayas and the Andes, Andes Parvatal under Andes mountains, right? Andes and the Sierra, Sierra Nevada and also some of the Rocky Mountains, right? So these are the examples. So in India, Himalaya is the uh, most example in India. Next one is mountain chain. So mountain chain means mountain chain consists of several parallel long and narrow mountains of different periods. So that's called mountain chains, right? This is the picture of the mountain chain. And next one is mountain system. So mountain system, you see this picture. So a mountain system consists of different mountain ranges of the same period. Remember, the same period, right? So in a mountain system, different mountain ranges are separated by valleys here, like that. Okay, valleys. These valleys. Okay. So a mountain system is a broader and more encompassing term that refers to a group of mountain ranges. So that share a common origin and structural characteristics, right? So it encompasses a larger geographic area and it may be include multiple mountains, mountain ranges and plateaus and also these valleys, right? Valleys. So the mountain systems are often formed by large scale plate tectonic movements and represent distinct geological provinces, right? So for example, you see here, this is the Rainbow Mountain in China, right? So this is the Rainbow Mountain. You see some of the colorful mountains are here, right? And also in India, Alpine Himalayan mountain system is there, right? That is also one of the example. So now you see the difference between mountain system and mountain belt. That is one of the important thing here. What is the mountain belt? So mountain belt is a mountain, it is an even broader term. So that refers to a large and elongated zone of these mountains. So that extends over a vast continental area. Vast continental area. So it is typically associated with a major orogenic event such as the collision of tectonic plates, right? So the mountain belts often consist of these multiple mountain systems, and it represent zones of intense geological activities. So some of the examples of these mountain belts include the Alpine Himalayan mountain belt, right? And also mountain group is there here. Mountain group means, so it consists of several unsymmetric, systematic, sorry, unsystematic patterns of different mountain systems. That's called mountain group. So last one is cordillera. Cordillera, right? So you see this picture is Cordillera. So it is a Spanish term. It referring to a system or major group of mountains, right? Major group of mountains. So a cordillera consists of several mountain groups and systems, right? So in other words, we can say cordillera is a community of mountains having different ridges and ranges and mountain chains and mountain systems totally, right? So Different ridges is there, different ranges is there, and different mountain changes, and also different mountain system is there. So that is called cordillera, right? So it is usually refers to an orogenic belt that at a continental scale. So example is the Western Cordillera of the USA, so which include all the ranges between the Pacific and the Great Plains. Okay. So, so Cordillera is a major system of often parallel mountain ranges that includes, what is that? The interventing plateaus, values, and also plains chains, right? So the Cordillera is a major system of parallel mountains, right? So the term is Spanish and it dates from the easily 18th century. It derives from the old Spanish word that is Cordilla. So which was the diminutive form of Cuda. Cuda. So it means cord. It means cord and string or rope. Okay. So this is the Spanish word. So next one is okay, classification. This is also a very important question in your examination. They are asking. Okay. So write about the classification of mountains or types of mountains. They are asking the 10 marks question in your examination. Okay. So now you see here, we have five types or five classifications of mountains here. First one is relict type of mountains, or it's called residual mountains. And second one is deformation type of mountains or tectonic type of mountains, and also fall type mountain, fold type mountains, and accumulation type of mountains are volcanic mountains and dome mountains. And finally, fifth one is mountains on the sea floor. So now we're going to one by one. So relict type are residual mountains. So relict are residual mountains. You see here. So some of the example Araval is in India and also Russia. In Russia, Urals mountains. So these are the remnants of old fold mountains. It derived as a result of denudation. Denudation means a strip of covering, right? So the residual mountains may also evolve from plateaus, so which have been dissected by rivers into hills and valleys. Okay, it's hills and valleys. So examples of dissected plateaus, so where the down cutting streams have eroded the uplands into mountains of denudation. So these are highlands of Scotland, Scandinavia, and also in India, Deccan Plateau, right? So the residual mountains also known as erosional mountains, right? So these are, what is that? Landforms that are created through a process of, what is that? Erosion. Remember this word, erosion. So these mountains are the remnants of much larger mountain ranges eroded to their core, right? So now, how to form these residual mountains? Residual mountains from through a series of some geological processes that involves, first one is uplift, uplift, and second one is weathering, okay, and third one is erosion, okay, uplift, weathering, erosion. So a mountain range may form through tectonic activity, right? So these activities include the collision of tectonic plates or the uplift of crustal blocks, right? So these mountains are characterized by their height and steep slopes and also topography, right? So now, what is the characteristics of these mountains? So these mountains exhibit several characteristics so that differentiation them from other types of mountains. And so some of the characteristic is rounded and weathered profiles. Rounded in weather profiles. So the residual mountains have rounded and weather profiles. It is due to the prolonged exposure to weathering and erosion. So the original mountain range, sharp peaks and rugged features. So those are gradually warmed down. So it results in a more subdued and rounded appearances, right? And we have steep slopes. Steep slope means uh, that mountains have undergone extensive erosion, right? So they still retain steep slopes, right? Steep slopes. So the erosion process may remove material from the peaks and ridges, right? So the remaining slope can remain steep due to the resistant nature of some different types of rocks. So it is also continued due to downward erosion, right? So these mountains may have flat tapped plateaus and also mesas at their summits, right? So mesa and butte, it means mesa means flat tapped mountains. It's called this like this. Okay. So butte means like this. Okay. And also we have V-shaped valleys is there. So V-shaped valleys that have been carved out by rivers, right? Right. So these valleys are these V-shaped valleys are the result of the erosive power of flowing water like this. Okay. Erosion, power of flowing water. The flowing water gradually, what is that? Cuts into this landscape and deepening and widening the valley. Okay, like this. These are some of the V-shaped valleys. So the residual mountains, these are the remains of historic fold mountains that have been exposed due to denudation. It means strip of covering. I already told about this, right? So examples, Nilgiri, Palakonda, Parasnath, some of the name, and also Rajmahal as well as mountains such as the Aravali, Vindhya, and Satpura. So these are the examples of the relict mountains in India. What is that? Aravali, Vindhya, and Satpura. These are the only in India, right? This is residual mountains. And next one is original or tectonic mountains, right? So these mountains are formed due to this large scale movement, right? This movement, large scale movements in the this tectonic plates and sorry.
Yes, ma'am. Movement of tectonic plates. Because of movement of tectonic plates, these mountains.
Right. Movements of tectonic plates and the resulting collision and folding of plates. It's called folding of plates, right? So these mountains are further classified into two types. That is fault block mountains and fold mountains. It's called fault mountains or fold mountains. You can say anything, right? So first one is fault mountains. What is the fault mountains? You see here, the fault block mountains are bounded by high angle normal fault here. You see here, this fault, okay? So some of them are associated with this rift valleys. Rift valleys such as those in the example is East Africa, while others appears to be formed by vertical uplifting, right? So the fault block mountain is found in the basin and range province of the southwestern USA. This is also one of the example. So, and also the salt range of Pakistan. And also Siena, Siena, Nevada of California. This is also USA. So these are also the typical examples of fault block mountains, right?
Yes, ma'am.
Next one is fold. You see here, this is the fold mountain. So this folded mountains comprise the largest and most complex mountain systems, right? So although the folding is the dominant characteristic and faulting and igneous activity. So these are always presenting varying degrees in these folded mountains. So examples of the Alps, you see here, the Alps, Himalayas, Rockies, Andes, and Appalachians, and Tian Shan, and Caucasus, and Elborz, and Hindu Kush, right? These are the all of these type examples. So the folded mountains present the world's most major mountain systems, right? So they are the youngest mountains in the world, right? So next one is volcanic mountains. So volcanic mountains, what are the volcanic mountains? So these are formed from, what is that? Extrusion of lava and lava and pyroclastic materials. Pyroclastic materials. So just wait. So now what is the pyroclastic materials? Anybody tell me? So this is the 5 marks question. In your examination, they are asking pyroclastic material.
Which is easily flammable material. Pyro means fire.
From which place? Volcanoes, right?
Yeah.
So which if continued long enough and it produce a gigantic volcanic piles, right? So some of the example is Kilimanjaro. Kilimanjaro in Africa, right?
Yes, ma'am.
And also Cotopaxi, this is Andes, and also some of Hood and Shasta, USA. Hood and Shasta. Hood, H-O-O-D. wood, and Shasta. This is USA. So these are some of the examples of the volcanic mountains. So the volcanic mountains is also known as mountains of accumulations, right? Mountains of accumulations. Those are generated by the buildup of volcanic debris, right? So the volcanic debris is throughout and then lands in a mountain like shape surrounding the crater. So if the lava is thin and basic in composition, it spreads across a large area. It generating a flatter core with a lower elevation and a softer slope. So some of the small volcanic cone sharply that is sticking out is the consequence. So if it is thick and acidic composition, right? So lava and ash and cinders. So these are sometimes flung out with the lava. So ash and cinder. So these cones are two types of volcanic cones. So examples, Mount Mana. Mount Mana, I think there. Okay, Mount Mana, M-O-U-N-T, Mount M-A-U-N-A, Mount Mauna Loa, L-O-A. So in Hawaii Island, right? Hawaii Island. And also Mount Popa, P-O-P-A. So that is in the Myanmar. And Fujiyama,
Japan.
F-U-J-Y-A-M-A, Fujiyama in Japan, right? So these are some of the examples. So in your examination, you can write these about these volcanic mountains and you can write examples also. Okay?
Okay, ma'am.
Mm. Next one is so upward are domed mountains, right? So upward are domed mountains. So these are formed by magmatic intrusions and upwarping of the crystal surface. Okay. So the lava domes, batholithic domes, and laccolithic domes. So these are coming in your next semester, right? So, and also salt domes, right? So these are the examples of dome mountains. The Black Hill, remember this word, Black Hills of Dakota, and the Adirondack Mountains of New York. So maybe it is cited as the examples of upward domes mountains, right? So the dome mountains are formed when anybody tell me? Okay.
When there is a
Okay, right. I'm telling you. So that is hard molten material. It's called magma, right?
yes, ma'am.
Hard molten material. So that magma is rising from the Earth's mantle into the crust. Crust forces the top sedimentary rock layers upward, right? So the time that this type of mountains are formed there. So thus they form a dome-shaped structure, right? So unlike a volcano, magma here rarely reaches the surface of the earth. Remember that, surface of the earth, right?
Yes, ma'am.
So here some domes mountains uplift from crust movements, right? So the lift can happen from plates, volcanoes, or magma, right? Some of the plastic deformation is there. So that is the uplift rock layers undergo plastic deformation. So it causes them to bend, right? It bend and buckle, forming a dome shape. And also some of the erosion and exhumations. So as the dome continues to be uplifted, that is called erosion and exhumation. So the erosion process is like weathering. So the domes get eroded by water and also wind, right? So, and characteristic. What is the characteristics of these dome mountains? So that means shape, structure, and core erosion. These are the some of the characteristics. So shape means, so dome mountains have a symmetrical or slightly elongated rounded shape, right? And it is, resembles an inverted bowl or dome, right? Bowl or dome. And structure. Structure means they typically consist of layers of rock, right? So the rocks are uplifted and folded, created a dome shape, right? And core. Next one is core. Shape is over, structure is over, and core. So the core of a dome mountain is composed of the this oldest and hardest rocks of resistant to erosion. So what is the oldest rocks and what is the latest means younger rocks? So suppose this is the layer of the earth and this is upward, right? So this is downward. So here some of the rocks here and here also some of the rocks here. So these are the younger rocks and these are the older rocks, right? It's called younger rocks and older rocks. So in this, the
Yes, ma'am.
core of dome mountain is composed of these oldest and hardest rocks of often resistant to erosion. And erosion means over time, erosion means wind, water, and ice, right? It can wear down the outer layers of the dome. It is exposing the core. So these are the characteristics of the dome mountains. And next one is, so oceanic mountains or seafloor mountains. So the oceanic mountains are found on continental shelves and oceanic floors, right? So if the height of the mountains is considered from the ocean floors. So that is, for example, is here you see this one, Mauna Kea. This height is how much? You see here, 9140 meters, huh? Right. So it would be the highest mountain, right? Highest mountain. It is a dormant volcanic mountain in the Hawaii hotspot volcanic chain, right? So most of the ocean mountains are below the water surface or below the sea level, right? So the oceanic mountains are located on continental shelves and ocean floors. So some oceanic mountains are also well above sea level, right? So if the height of the mountains is considered from the oceanic floor and not from the sea level, right? So many of the oceanic mountains will become much higher than the Mount Everest. Remember this, Mount Everest. Where is it? Mount Everest? Mount Everest. Anybody? Mount
Mount
Everest
Everest,
ఎక్కడ ఉందమ్మా?
Nepal.
Nepal, right. Very good. Right? So many of the oceanic mountains will become much higher than the Mount Everest. Mount Everest is the highest, right? So for
Yes,
example,
ma'am.
yeah. So this Mauna Kea volcano, this mountain. So this is Hawaii Island. So that is 4,200 meters. 4,200 meters high from the high from the, what is that? Sea level. Sea level. But if its height is considered from the sea bottom, remember this word, sea bottom. Okay. So its height becomes 9140 meters, which is higher than the highest mountain. And Mount Everest height is the 8848, right? 8848 meters of the continent, right? So similarly, the Antillean mountain also is there. Antillean mountain system is how much? 3,000 meter above the sea level. But it is also 5,400 meters below sea level, right? Below sea level. Above sea level means 3,000, right? 3,000. And below sea level is 5,400 meters, right? And thus its total height from the oceanic floor becomes 8,400 meters. That is Antillean mountain, right? So most of the oceanic mountains are volcanic mountains. Okay. So the oceanic mountains are found on continental shelves and ocean floors. So if the height of the mountains considered from the oceanic floor. Okay. This is the Mount Kia, a dormant volcano in the island of Hawaii. This picture. Okay. You see here some of the high mountains here. Mount Everest and Mount Kilimanjaro and Mount Fuji and Mount Vesuvius. So these are some of the height mountains. And you see here types of mountains in India with examples. You see here Himalayan mountains, right? So example, Mount Everest and Kanchenjunga and Nanda Devi. So this Mount Everest, Kanchenjunga, Nanda Devi, this is the Himalayan mountains. And Western Ghats. Western Ghats is there, that is Anaimudi, right? Anaimudi and Dodda Betta, right? Dodda Betta and Mulayangiri. And Eastern Ghats, Armakonda and Jindagada Peak and Palamalai Hill. And Aravali means Guru Sikar and Mount Abu. And Vindhyans, examples, Amarkantak Hill and Mahadev Hills and Satpura and also Nilagiri, Western Himalayas, Eastern Himalayas, Karakoram and Sivalik and Eastern Coastal Range. So these are some of the examples in India only, not outer, only in India. So you can write some of the examples, this one, okay? So just wait. This orogeny over. So next is earthquake. Okay, earthquakes. So earthquake, maximum all of you know about the earthquakes. So what is the reason? How it
Tectonic plates.
came regarding
When there is a movement in tectonic plates, earthquakes occur, man.
tectonic plate? Right, very good. So earthquakes are highly destructive natural disasters, right? Is it natural or not?
Natural, man.
Is it natural, right? So natural disasters, it leading to significant loss of life and also extensive damages to property on a global scale each year, right? So in response, the Disaster Management Committee has implemented various safety measures to minimize the devastating effects of these catastrophic events, right? So there's some of the developing effective strategies and promoting disaster management awareness that is paramount in mitigating the impact of earthquakes and ensuring our safety, right? So you see here, what is earthquake, right? So an earth, you see here, the shaking of the earth surface caused by a sudden release of energy within the earth crust, right? Earth crust. So then earthquake refers to the shaking of the earth, right? Shaking of the earth surface. It caused by a sudden release of energy, right? Sudden release of energy within the earth crust. So this release of energy generates seismic waves, right? And commonly it is known as S waves. S waves. Okay. So the intensity and characteristics of an earthquakes are determined by the seismic activities occurring in a some specific region. So during an earthquake, the stored energy accumulated within the earth crust. So that is suddenly released, right? It leading to the rapid movement and displacing of rock masses along fault lines, right? So this movement produces vibrations that propagate through the earth in the form of seismic waves. So the seismic waves are not two, three types, right? So first one is S waves, and second one is P waves, and third one is L wave, right? So S means secondary, P means primary. So S waves also called shear waves, right? Shear waves. So it traveled through the earth by causing particles to move perpendicular to the direction of wave propagation. So these waves are responsible for the side-to-side shaking motion experienced during the earthquake, right? And on other hand, P waves. So P waves means it calls compression waves, right? It causes particles to move in the same direction as the wave propagation. You see here first P waves, right? This is the S waves, okay? This is P waves. So P waves are the first detected during an earthquake, and these are responsible for the initial abrupt joint, right? So, and next one is L waves. L waves means love waves. So these are created when these particles vibrate perpendicular the propagation direction, right? This direction. So while the particle motion is similar to that of shear waves, so love waves amplitude is much higher and decreases rapidly with depth. Okay, so these waves are the most destructive waves in earthquake because of their height, amplitude, and transfer particle this particle motion. Okay. So some this understanding the nature of earthquakes and the behavior of seismic waves is crucial for assessing the potential associated with these natural disasters. So it enables scientists and experts those are to study seismic patterns and develop early warning systems and establish building codes for the earthquake resistant structures, and also educate communities on preparedness and also response measures, right? So these are the three types of the seismic waves: P waves, S waves, and L waves. So now, so what are the causes? What are the causes in earthquake? So earthquakes occur due to sudden tectonic movement, right? So within the earth crust. So the earth crust is divided into large sections, that is called tectonic plates. Tectonic plates. What is that? Earth crust is divided into two large sections. Okay. So it's called tectonic plates. So which float on the semi-fluid layer known as the asthenosphere. Asthenosphere. What is the? Which float on the semi-fluid layer is known as the asthenosphere. So these plates, these tectonic plates are constantly in motion, albeit it very slowly. So when these two tectonic plates interact various type of boundaries, it can form such as convergent and divergent and transform boundaries, right? So the most powerful and destructive earthquakes typically occur at this convergent boundaries. So where two plates collide or slide past so each other, right? So at this convergent boundary, one tectonic plate may be forced beneath another in a process called subduction. Subduction. This one tectonic plate may be forced beneath another, right? So that process is called subduction. So as the plates collide or side past each other, that immense pressure and friction build up. So eventually the stress becomes too great. It causes the rocks along the plate boundaries to break and slip, right? So this sudden release of stored energy generate seismic waves, that is resulting earthquake. Okay. So in addition to these tectonic movements and other geological activities that can also trigger earthquakes. So the volcanic activity, for instance, it can causes earthquakes when magma rises through the earth crust and creating pressure and fracturing the rocks around the volcano, right? So the disturbances, some of the disturbances is there, right? So the disturbances caused by these movements and ruptures within the earth crust, it generate vibrations that propagate in all directions, right? So, and shaking the ground. So that's called earthquake. So these vibrations are the seismic waves. So that travel through the earth and those are detected by seismographs. So it's important to note that the buildup of stress and the subsequent release of energy in the form of shock waves are fundamental mechanisms behind the earthquake, right? Right, you see here. So what are the effects of an earthquake? You see here, this picture. So earthquake can have a wide range of effects, right? It varying in its severity of depending on factors such as the quake's magnitude and the depth of its epicenter and the local geology. So here are some of the primary effects caused by the earthquakes. You see here, ground shaking, damage to man-made structures, fires and hazards, chemicals spills, and landslides and avalanches and tsunamis, right? So, ground shaking. Ground shaking means ground shaking means when an earthquake occurs, the release of energy creates seismic waves. So that cause the ground to shake, right? So the intensity of the shaking, it can vary depending on factors such as the magnitude of the earthquake, the distance from the epicenter, and the local geology. So these areas closer to the epicenter usually experience more intense shaking, which can significantly damage structures and infrastructures. And second one is damage man-made structures. So one of the most noticeable effects of an earthquake is the damage it can cause to buildings and bridges and also roads, right? And other man-made structures. So the shaking can lead to structural failure and collapse and also extensive damage, and especially if the buildings are not designed or constructed to withstand seismic activity, right? So the severe severity of the damage, it depends on the factors such as the quality of construction and adherence to building codes and proximity to the epicenter, right? And third one is fires and hazardous chemicals. This is very dangerous. So earthquakes can trigger secondary hazards such as fires and hazardous spills. So the violent shaking can rupture gas pipelines and damage electrical systems and disrupt infrastructures and leading to the ignition of fires, right? So this is also very dangerous. So additionally, the earthquakes can cause the release of hazardous chemical stores in the industrial facilities and posing risk to human health and the environment. So these secondary effects can further exacerbate the impact of an earthquake and complicate rescue and recovery effort, efforts, right? And fourth one is landslides and avalanches. So landslides in some of the areas with steep slopes, right? Steep slopes are unstable terrain earthquakes. It can trigger landslides and avalanches, right? So the shaking can destabilized, right? Destabilized slopes and causing rocks and soils and debris to slide downhill. So the landslides can damage structures, blocking roads, right? And even bury entire communities and leading to additional casualties and hindering rescues and relief operations access, right? And tsunamis, all of you know about these tsunamis. So tsunamis, where it will come? Tsunamis, is it underground the air?
Tsunamis occur when there is a huge water waves coming towards the land, when there is a
Right.
sudden movement underground
Uh,
oceanic flow.
Okay, right. So tsunami means underwater, right? Underwater earthquakes. It means underwater earthquakes, it can generate tsunamis. So particularly those occurring along tectonic plate boundaries, right? So these massive ocean waves can travel long distances and reaching coastal areas and causing devastating flooding, right? So the tsunamis pose a significant threat to coastal communities, and it can result in widespread destruction and loss of lives, right? These are the tsunamis. Now you see here, so this is the seismograph. So, is seismograph and Richard scale. So, these are essential tools used in seismology to understand and characterize earthquakes. So, while they are related to each other, they serve different purposes. So, here an elaboration on the difference between seismograph and the Richard scale here. So seismograph is a device used to measure and record the vibrations or ground motions caused by earthquake. And it consists of a ground motion sensor, and typically it is a mass attached to a fixed base, right? A fixed base and a recording system that captures the movement detected by the sensors, right? And seismographs are essential in monitoring seismic activity, and they provide valuable data about the intensity and duration and frequency of the ground shaking, right? So by analyzing the recorded seismograms, some of the scientists can determine the various characteristics of an earthquake, such as its magnitude and location, and also focal depth, right? So the seismographs also detect other seismic events such as volcanic eruptions and also underground explosions, right? This is seismograph. So now Richard scale. Richer scale. Richer scale means it is developed by, who is that? Charles F. Richard in the year of 1930s. So it's a numerical scale used to quantify the magnitude or strength of an earthquake, right? So it measures the energy released during an earthquake by analyzing the amplitude of seismic waves recorded on seismograph. Okay. So the Richard scale is a logarithmic. So it meaning that each whole number increase on the scale corresponding to a tenfold increase in the amplitude of the seismic waves, and approximately how much? 31.6 times more energy released, right? So the Richard scale provides a standardization measurement for consistent comparison of worldwide earthquake magnitude, right? So these are the difference between seismograph and Richard scale. And you see some of the example here, Nepal earthquake before picture and after picture. Okay, this is in Nepal. So these are some of the importance of understanding seismic activity mitigation and preparedness and risk assessment, and also engineering design and public safety and scientific understanding. So these are some of the important understanding about seismic activities. Okay. Okay. So today class is over. So what is that? No, in the ocean or underwater earthquakes. Now, please maximize screen. Okay. When will be the practical exams in date of written exam?
Ma'am,
So
when
it
can
will
we come
take.
for stamp? Like, only book, half book is corrected.
So
And stamp is.
stamp is not necessary. Stamp is not necessary. So we are verified and signed these. Okay.
Okay.
In
Yeah, half
at
book is
the
corrected.
examination time.
Yeah, half book is corrected and remaining
Which
9
ma'am?
diagrams. You
In
told
the
them, ma'am, later.
practical.
Yeah, in the practical, you told you'll correct later.
Yeah,
Like, half
yeah.
book is completed
Yeah.
and half book is not corrected.
So while coming to the examination, you can bring the manuals. I will correct it. Okay.
Okay, ma'am. So stamp is not required.
Not required.
Okay, ma'am.
Okay.
Thank you, ma'am.
Okay. Any doubts? No.
No, ma'am. Clear.
Okay. Okay. Okay, then
Okay,
bye.
okay, ma'am. Have a great day.
Mm. Thank you.